So now we're going to discuss how we can use these risk measures. So these methods adjust time-weighted returns for risk to allow for comparisons. So just like with making any other comparison, I mean, your teachers have been telling you forever, you can't compare apples to oranges, right? So make sure that you compare one high-yield bond fund versus another. And even then, there's still some issues that must be addressed. So the first thing we're going to talk about is the Sharpe ratio. So this one's the most obvious. So realized return of your portfolio minus the risk-free rate scaled by the standard deviation of your portfolio. So this is what we optimize when we are doing the Markowitz optimization, right? So this is the reward to total volatility trade-off. The trainer ratio, this one's appropriate if we were using systematic risk only. So if you use CAPM or use a single index model, then trainer is what we would look at, because here we're measuring risk relative to the market only. So it only uses systematic risk. Now, alpha is actually included in both of these. So alpha does have an impact because alpha impacts that rate of return that you have on your portfolio. So remember, your alpha value is the rate of return, Jensen's alpha, right? What you would see here, the rate of return above that you receive above that which would be predicted by CAPM. So with the Sharpe ratio, the way that we would think about this, we could say, all right, well, there is no alpha, the risk-free rate of return, right? So this would be the alpha of your portfolio scaled by the standard deviation of your portfolio is the way to look at it. And here it's the alpha of your portfolio scaled by the beta of your portfolio. So superior performance does lead to a positive alpha, but Sharpe and Trainer use alpha differently. With a positive alpha, the Sharpe ratio would be lower because of the additional risk that you may be bearing. With the Trainer ratio, you wouldn't necessarily see that a positive alpha would reduce the Trainer ratio, because that alpha was not already included as a risk measure in here, because we're doing risk only relative to the market. So we're only looking at beta when we're using trainer. When we're using standard deviation, that looks at all risk, right? When we use beta, we only look relative to market risk. So you would see that if you have a positive alpha, your Sharpe ratio would tend to be lower as a result of that additional risk characteristics that you're looking at. So we're still going to be talking about alpha values. Alpha values are going to be very important. And then again, Jensen's alpha, this is just talking about how we calculated it. So the average rate of return on your portfolio beyond that which would be predicted by CAPM. So again, this is only focusing on systematic risk. And then we have the information ratio, which divides alpha by the non-systematic risk. So it measures abnormal returns per unit of risk based on the idea that risk can be diversified away by holding a passive market security. All right, so the question is, well, which of these ratios do I need to use? What one, when is it relevant to use either one? So in general, we would use the Sharpe ratio when your portfolio is your entire investment. You would use the trainer ratio when you're looking at how an individual asset contributes to a well-diversified portfolio. So if you are doing a full portfolio evaluation, meaning you're evaluating your entire portfolio, then Sharpe is going to be most relevant. If you're looking at how one asset or one group of assets contributes to the portfolio, then you're going to want to go with the trainer ratio. The next thing that you can look at for a risk measure is called the M-squared measure. And the M-squared risk measure creates an adjusted portfolio that we're going to call P star that has the same standard deviation as the market index, meaning it's just as risky as the market. So P star right there. Okay. Because the market index and P star have the same standard deviation, their returns should be comparable. If your return on your portfolio is less, and return on, this P star here is less than the market, the portfolio would have underperformed and vice versa. So here is an example. We have our managed portfolio, which had a rate of return of 35%. So that looks really good, and a standard deviation of 42%. We then had the market portfolio that had a rate of return of 28% and a standard deviation of 30%. The T-bills were 6%. So your portfolio outperformed the market, but it was also more risky. So it outperformed 35 versus 28, but its standard deviation was 42% versus 30%. So what we need to do is create an adjusted portfolio P star with the same standard deviation as the market. So the way that we're going to do that is look at the ratio of your standard deviation relative to the market. So the market standard deviation was 30, your standard deviation was 42. So 0.714 in P and 71.4% in P and 28.6% in T-bills would be how you would form P star. So find the ratio of the amount to put into the market portfolio, and then whatever is left over is put into the risk-free asset. So the idea here, what proportion of our portfolio, is made up of the market, and what, in order to get that same risk, right? Okay. So the return on P star, all right, well, it would be 71.4% of our portfolio's return plus the 28.6% of the risk-free assets return, and that came up with 26.7. So, okay, well, what does that mean? How do I interpret this? Here's my P star versus P. Well, this is saying that with our P star portfolio, because the market index and P star have the same standard deviation, their returns should be comparable. But if I look over here, the return on P, how did that work? The return on P actually would have been higher, right? So in this case, my portfolio underperformed because the rate of return on P star was less than the rate of return on the market. And that's the M squared measure, that difference between P star and the rate of return on the market. So comparing this to the 26.7 to the 28.